Greetings, I'm Ben, and in this video I'm going to show you how to use R to create variables and get descriptive statistics for those variables. So let's jump right in and learn how to get frequencies for your categorical variables. And I also find this useful to visually inspect the variables that are at an interval ratio scale just to make sure that they look appropriate. So we'll start with a race variable. We're going to use the pilot data from the ANES 2020 survey, and I've uploaded it and named it ANES. So if I want to get the names of all the variables in the data set, I can use the command names, and I find this helpful in case I forgot what a variable is named, or if I just need to look at what all variables are in there. So the command is names, and then in parentheses you just put the name of your data set, and I happen to have named this data set ANES. Now, the variable that we're interested in is race 7, and we want to know how many people exist within each category, and we would need the code book to figure out, what number corresponds to what category. But for our purposes, we'll do table, and so this is the command, table. And then in parentheses, you need to start with the name of the data set, because you could have multiple data sets in here, or you could ask for a table of some vector that's not in a data set. And so you need to tell R where to look. So tell it to look in the data set ANES, and then you put the $ to say within that data set, I want you to look at the variable and then the name of the variable. And so this variable is named race 7, and so that's what we've typed. And with this command, we get a table. And so we see 1, 2, 3, 4, 5, 6, 7, 9. This top row is always the response options. And then the bottom row are how many people exist within each category in the data set. And we would have to say, okay, 2,161 is in the first category. And we would need to look at the code book to verify what you probably suspect, which is that this is the white Caucasian. And then we have 2 and 5, are the next most represented categories in the racial category. And odds are one of these is Hispanic or Latinx, and the other is African American or Black. And to know which is which and what these other numbers correspond to, we would need to look in the code book. But here we have a table with the the number of people in our sample in each category. Now you'll notice it goes 7, 9. And if it's a secondary data set that you're using, like the ANES, you always want to check the codebook because this 9 in ANES actually corresponds to missing. So there are 2 people in the data set that we don't have race values for. And so we may want to change this from the number 9, which looks like an actual relevant category, to the value that R understands to mean missing, so that R knows that these 2 cases are actually missing data. And a good way to do that is with the Recode command. And the Recode command is in car, the package car. So you need to make sure that you have the package car installed and loaded. When you have car installed and loaded, you can use the Recode command. And to do that, you would start with the new name you want for this variable. So you could say race 7, and this would create a new variable, and it would actually write over the existing variable. So if you're not sure that you want to write over the existing variable, if you think you might want to keep the original variable, then you might give this a unique name like race 7R to indicate that you've recoded it. But I'm cocky. I think I'll probably do this right. So I'm just going to keep it ANES race 7. And then, of course, you put this little caret to say, I want you to create this variable, race 7, and put it in this data set. And the thing that I want you to create and put there is what will be on the other end of this little arrow. So we will use the command recode, which is a command from the car package. So if you don't have the car package installed and loaded, then this won't work. I should also say that if you have dplyr loaded, the package dplyr, which is right here, if this is loaded, it also has a recode command, and it will take priority. And the recode command will write over your existing variable with an empty vector because the syntax is different. It'll basically delete the variable. So make sure if you're using both car and dplyr for different things, that if you're going to use car for recoding, you don't have dplyr loaded. Okay, that caveat aside, we will go recode, and then we say the name of the variable we want to recode, which is ANES race 7, and then comma, quotation marks. We want to recode the value 9, and we want it to be NA. So NA is what R understands to mean missing. So by typing this, it'll keep 1, 2, 3, 4, 5, 6, 7 all the same, but 9 it will replace with NA. And so if we run this and then ask for the same table as before, you'll see it'll give us the same values, but it won't show us the 2 missing. So that is how you can deal with missing data. Now, all that does is delete the 9s and replace them with NAs, and then R understands those NAs to be missing values. So if you need to impute or in some other way recapture the missing data, then obviously this won't work. But this will communicate to R that those values are missing. Okay, let's do another one. Let's get a table for age. Okay, so we want to, oh, I'm sorry, actually, let's do another. I want to show you something else. I want to show you how to get the percentages for your categories, because you can say, okay, so we have 2,161 people that are white or Caucasian, but what percentage is that? So you can do prop.table, so this is a proportion table, and then in parentheses, table, and then in parentheses again, ANES $race 7. And so that's prop.table in parentheses, the previous table command that you ran before. And so this will tell us that about 70% of the sample is white, Caucasian, and it gives us the percent for, well, it gives us a proportion, which you can easily convert to a percent by moving the decimal for all of the other categories. Okay, now, if you want to describe age, you don't actually want the number or percentage, you want the mean and the standard deviation of the age. And the command that I like to get those descriptive statistics is the command describe. And the command describe exists in the psych package. So here you'll see I have both sci and psych loaded. You'll actually see there's also this quant psych package, and it also has a good describe function, but for whatever reason, I use the psych package and its describe function. So I can say describe ANES $, and this variable is labeled age. And this will give me the number of people that have their age reported, the mean or average age, so 48.87, the standard deviation of the age. It also gives me the median, the minimum, the maximum. You can see here the minimum age is 18, and that's useful, right? Because for my research, I can't ethically use people under the age of 18 unless I know that I have their parents' consent. So it's helpful to know that there's nobody under the age of 18. And then max 110. Now, when I saw that, I thought, okay, is 110 the maximum age in the data set observed in the sample, or is it somebody who was, who didn't provide their age, and therefore, 110 was some sort of code for missing. And I looked at the code book and didn't see any indication that it was anything other than actually there is a 110-year-old in the data set. It's also useful, I find, to get the table for even interval ratio level variables like this, just to make sure that the values all make sense. There's no -99 or 999. And you see it says, yeah, there's one person that was 110, one person 92, two people were 90. And it just, 29 people were 18, 44 people were 19. Another good way to summarize and inspect your data to make sure everything checks out is to get a histogram. And the command to get a histogram in R is quite simple. HIST, histogram. And then in parentheses, you guessed it, ANES $age. And so we run that, and it will give us a histogram of all of the ages. And so we can inspect the histogram to make sure that everything looks appropriate, and it'll also give us a sense for how the variables are distributed. And I think that the x-axis of the histogram is off screen for this video, but the x-axis shows you the values of x, and then of course the y-axis will show us how many people are in each general region of the axis. So the histogram command is very useful for summarizing data. Describe is a useful function. Table is a great function. The last thing I want to show you how to do is how to compute a variable. And I'm going to show you, to see how to compute a variable, I'm also going to show you how to recode the variable. So let me show you this. Well, let's see. Hold on. That's not where I want it to be. This does show you that the that 9 was coded as missing in the code book, but I actually want the racial resentment scale. So there are 4 items in the racial resentment scale, so we're going to use these 4 items to create a composite. And as you can see, the first one is Irish, Italians, Jewish, and many other minorities overcame prejudice and worked, and it goes on. And if you can look at the political science research on racial resentment to see the full wording of these items. But you will see that the scale goes from 1 to 5, from strongly agree to strongly disagree, and that 9 is the code for missing values. And then you'll also see racial resentment 2. Generations of slavery and discrimination have created conditions that make it, and this item is that make it difficult, and this is reverse coded. So people who agree that this item basically says that because of slavery and discrimination, black people have a more difficult time getting ahead than white people. And people who strongly agree with that statement are low in racial resentment. Whereas people who strongly agree with this statement are high in racial resentment. And people who disagree strongly are low in racial resentment. And then here we have, over the past few years, blacks have gotten less than they deserve. So again, people who strongly agree with this are low in racial resentment. So these two, racial resentment 2 and racial resentment 3, are already coded the way we want them to, where somebody who disagrees strongly with this statement is higher in racial resentment. And somebody who disagrees strongly with this statement is high in racial resentment. But this one's coded backwards. Somebody who strongly disagrees is actually low in racial resentment. Somebody who strongly agrees is high. So we need to reverse the coding of this one. And we need to do the same for this one. It's really a matter of some people not trying hard enough. If blacks would only, and then it goes on to say, work harder, they wouldn't face barriers or problems. And so again, if you strongly agree with this statement, that indicates that you're higher in racial resentment. And so we need to flip the coding of racial resentment 1 and 4 so that strongly agree corresponds to a 5 and strongly disagree corresponds to a 1. And on all 4 of them, we need to get rid of the missing values. So how do we do that? Well, the first thing we can do, let's see, so we're going to use the same recode command. So we'll go ANES RR1. And again, here, I'm writing over the existing value by giving it the same name. If I changed it to capital RR1 or, race resent 1 or anything else, it would create a new variable. But this is going to write over my variable because I'm using the same name. So, shame on me. I don't have to. ANES RR1 and then comma. So again, recode is the command. ANES RR1, comma, and then in quote marks. Now this one, remember, I want to recode all of the values. So I want 1 to equal 5. So people who had strongly agree now have the higher value, 5, 2 to equal 4, 3 to equal 3. You don't actually have to do this. It's redundant. I just do it because visually it helps me. 4 equals 2, 5 equals 1, and 9 equals NA. So here I'm taking the 9s and turning them into missing values. I'm taking the 5, strongly disagree, and making it correspond to strongly agree, 1. And the 4, agree, changing it to disagree. The 3 stays the same. The 2 goes from disagree to agree. And the 1 goes from strongly agree to strongly disagree. So this will flip the values. So we can go table ANES RR1. And you'll see, right now we have 968 people with a 1, and 350 people with a 5, and 4 people with a 9. And I wonder if this has already been recoded. I bet it has already been recoded. Maybe I already did this when I was practicing. So you'll always want to make sure that you're not, because I believe that most people strongly disagree with that statement, and that anyway, I'm just showing you how to do it. The mechanics of it you can understand. So I run that and it flips it, and so now you'll see 350 people have a 1 and 968 people have a 5, and there are no more 9s. And so we want to do the same thing for racial resentment 4, right? Because remember, that was the other one that was reversed. And so I'm just changing this from RR1 to RR4. I'm changing this from RR1 to RR4. And otherwise, the syntax is identical. Now, with racial resentment 2 and 3, all I need to do is get rid of the 9s and turn them into NAs. And so I don't want to reverse code those items. I just want to turn all the missings, all the 9s, into NAs. Okay, so now I have my 4 racial resentment items. I've recoded the ones that were reverse coded, and I've gotten rid of the missing values where necessary. Now I can create the composite variable. And this is actually quite simple. So we say, okay, in the data set ANES, I want you to put something, a new variable. And we'll call it racial resentment, RACRES. And this is not something that's in the data set now, so it's going to be a new variable, a new value. And then in parentheses, we just put ANES RR1 plus ANES RR2 plus ANES RR3 plus ANES RR4. Oops, I forgot the $sign there. And I'm going to bring this down so that it's easier to see. And then we just divide by 4. So all this does is add the 4 racial resentment variables together. And then this divides it by 4. And so this will give us the average of the responses to those 4 items. And that is our scale. Then we describe ANES, the new variable that we created, and this shows us that the mean is 3.12 and the standard deviation is 1.04. And of course you'll want to verify, like I said, I do think that these were already reverse coded, whether that's something that I did when I was fooling around and practicing, or whether that's something that happened when that they did it in the data set so that you wouldn't need to. Hopefully they didn't without mentioning it. But it's actually pretty easy to check if we want to go back to the figure. It shows that, let's see. So it shows here that actually, no, we did it right. There were 968 people that strongly agree with this item, that white minorities overcame prejudice and worked their way up, so other minorities should have to as well. So interesting. So then we reverse coded them appropriately and got the mean and standard deviation, and everything checks out. So that is how you can get that's how you can describe variables, get your frequency tables and your percentages, and get your means and standard deviations. It's also how you can reverse code variables or recode variables in any circumstance when you need to recode your variables, and how you can compute new variables. I hope you found all of that interesting. I hope you found it valuable. And please be sure to let me know in the comments if there's something else you'd like to see a video tutorial on. Thanks for watching.